everybody does it a little bit differently, okay?
Yeah.
So what we're doing on ours is we're fused on the positive side. So you see that huge fuse, right?
Yeah, the white one.
White one. So I mean, the intention there is, let's say you had a direct short of the motor. That would stop it from, you know, pulling excess current that would go crazy, right?
Right.
And would burn your battery down. So the purpose is, I think it's 1,000 amps or something, right?
Okay.
So that exists there. Other components in the box are, you know, to engage the motor is relay controlled. So you can see at the bottom of the box, coming from that high power.
The black circular item?
Yeah, towards the bottom left.
Yeah.
So if
oh,
you,
bottom
yeah,
left. I'm looking bottom right.
Well, there's another one there. That's on the negative contactor. So we also, I think we switch both. We switch the positive and negative on and off, right?
So you got two relays at the bottom there.
Yeah.
Those look like really high amperage as well.
Exactly, right?
Okay. Yeah, you're way down low.
Yeah. Maybe I have to look. It's been about a year now, and now I'm forgetting if I was switching the negative as well. I'll clarify that with you afterwards. So we switch the motor on and off, and we go through that pre-charge resistor, so we ramp that current slowly to it. When we do the first key on, we're actually also engaging. The first key on engages the charger circuit and also the DC to DC. So you see those are smaller relays.
Okay.
So on the top is the DC to DC connector. So he's also switched on the first key, and so is the charger. So when you're charging, you're just key on, but the motor's not connected. And then when you're done charging, you go to the next position, and that'll connect the motor. Okay. So we're using relays to do all that control, and all the control just comes from the key switch. Right, so it's not terribly complicated to engage.
So turning the key makes the contactor, but you still haven't thrown any amperage at it yet. I
Right.
assume
the amperage
the
really
gas pedal.
comes from the gas pedal.
Right,
yeah, being
okay.
in drive, neutral, reverse, right?
Yep.
And then, so that's what's happening when we're keying on, is we're connecting different components that I showed you earlier. We decided, so in a real car, you know, they would have temperature controllers controlling pumps and fans and what have you. We decided that for the motor inverter, we'll always, when we key it on, those fans and pumps are on, right? And then for the battery, we put switches on it, right? So the next level of integration would be to automate that. So some of the students were working on that. They were working on the logic, which would be interpreting the temperature of, let's say, the stator or something. There's one component in here that gets hotter than any other when you're really driving hard. Watch that and make decisions based on that, right? The other would be look at the battery or look at the charger and look at these two high temperatures and make a decision of turning pumps on or fans on. We didn't get there yet. So as you know, so it's not ultimately quiet. The thing, you're hearing the fans, right?
To start with, just turn it on and run it until you're
done.
Run
Run it till you're done. But I think second level refinement would be to put those controls in. So there is another person who's doing a build of a DeLorean, and he has really nice code for his controllers, for even to the point where he's using the Tesla pumps are variable speed, the water pump.
Okay.
So he's even using the variable speed of the pump in addition to when he kicks on the fans. And then the Tesla is using the AC of the car to actually cool things. So in this vehicle, we have a fan, right, controlling this is our dissipation of the battery. So the battery can never get colder than the ambient within this solution. But in the Tesla, the real car, they'll use the AC of the car to cool the battery. So they can really, and also in the Volt, they do that too. So they can tightly control the temperature of the battery. Ours is going to swing quite a bit, which, and so that being said, maybe that has a reliability impact, not having that tight of a temperature control. But to us in this application, it's fine, right? It's going to be okay. But the DeLorean person doing the EV DeLorean did really good work on how to use those existing systems, control the valves, because we're talking about switching not only the speed of the pump, but controlling the valves of the flow of the coolant, right? So it'll create different coolant loops for so he basically replicated what Tesla did or what the Chevy Volt did. But when we looked at it, it's nice, but it's just overly complicated for this application. So we didn't do that. But I think I I did put that valve in here. I do have the three-way valve, so I could actually use it if I needed to. But just driving it around, I don't think it's necessary. I mean, to one extent, you can go through all these systems and try to employ them, but you're going to delay finishing your build by years. I don't think I've seen his car yet driving, right? I think he's got tremendous engineering, but my focus was, hey, let's get it 80% there, and then let's work on the last 20% when we're ready to, right? So
it's more race car mentality. It's
right,
like, get it going.
Yeah, and it's surprisingly well sorted. There are things that we need to get better, but so the last two components I didn't talk about is the steering and the brakes, right?
Okay.
So the steering is electric assist, and it's from a Saturn view, right? So I don't know if your Goblin has that, but this has the electric power steering. You can see it under the dash.
We don't. I know some people who did independent harnesses use that because it can run as a standalone.
Right.
Somebody's
we
already
bought there's
dial
under the dash is that dial.
Okay.
Right. So right now we can control the assist level. It's quite assisted, and actually with the car being so light, you know, maybe we need to dial it back down.
So you're talking this thing, and you've got a resistor somewhere in here. I don't know.
Under the dash is a knob.
Okay.
So we have a knob down there that I don't know if you could see it, but it's down there.
Yeah, you adjust it once and you forget it.
Right.
Sort of a deal. Yeah.
And
wow, it's got a pretty good sized motor there.
Right.
I think that's bigger than the motor I've got in mine.
So I mean, Lonnie integrated all that. So he basically he procured the components for that and did that, right? And he built the car for us. So we bought this car fully built. Other than, and you know, it came to us with the motors mounted.
Okay.
With this mounted, he did a YouTube video where he did this is a Tesla Model S half shaft. He splined it for the Cobalt SS. Yeah, he did an incredible job getting that, you know, as beefy as we can get it, and properly machined. Mounted the motor itself. You know, I don't know what your Goblin looks like, but maybe it's a little bit different.
Well, I mean, mine has the suspension, the subframe. These shocks, I mean, obviously Lonnie this side would be the half that mine has, and that side is Tesla.
Right.
I mean, the suspension geometry here looks pretty much the same on the wheel side. Right. Of course, it stops right there.
Yeah.
Sort of a deal. Even this, that's different because my bar is back here where your motor is.
Okay.
You need that room, so Lonnie flipped things around or something to do that. But and wow, he did custom mounts here for your engine mounts. Right. There's a lot of custom work here. Yeah. I mean, this piece here is all custom engineered for you. Right.
And the fans, he mounted all the fans. I mean, so even the wheels and tires, all of that was done by him. We wrapped it. We had it wrapped. You know, we had but let me show you these other parts. So.
Wow. Okay.
Yeah.
I'm gonna.
Oh, okay. Yeah. I see. Yeah. Let me tell you about the last thing about the brakes is the brake booster. Okay. Right. So obviously we have no vacuum coming from the engine, right? So we had to create a vacuum source, and that's where we have a electric vacuum pump.
Oh, really?
And so we looked at, you know, what's the quietest we can get, and that's what's in here is a quiet electric vacuum pump. I don't know if you see it's a black cylindrical cylinder.
Oh, is it over top of the firewall there?
Yeah, right back there, right.
Oh, it looks like a big 2 horsepower motor or something.
Yeah, it's not. It's pretty efficient.
Okay.
And so that comes on and off based on, you know, how much we're using the brake. Okay. Right, and so that's how we're getting the vacuum boost. We could have gone Tesla. So Tesla has it's called the Tesla iBooster, I think was what it's called. It's actually an electric brake assembly, so it's all electric, and you can get this thing to, you know, replace a vacuum canister. But we said, okay, that's one level too much.
So what is the brake off of? Just a standard?
I think it's what's in your Goblin. It's off the Cobalt.
Yeah, right? Chevy Cobalt.
Yeah, Chevy Cobalt.
So is the brake booster still in there? And then you just got a vacuum pump to run it electrically.
Right.
Okay.
And then that's.
I mean, there's tons of brakes in this car, at least.
I think so. Yeah. And so that's the gist of it. You know, that's the other is, you know, we 3D printed some things. We built some things this is a 3D printed box you could see here.
Oh wow!
So this is the main kill switch.
Yep.
So all the power from the battery on the positive side comes through here, so we can kill the positive contactor right there. And we had to. since it's kind of a unique shape, we couldn't really find an exact fit box, so we made our own. And we did that on other parts of the car too, where we made things for it. And we water jet cut copper here to bridge the two terminals because it's only good for 500 amps. So we needed 1,000. So we were able to use two parts of the terminals by using a copper disc. Right. There was another guy that on YouTube that you should check out. It's Tesla Bimmer, and so he used these batteries, this motor. He used Damien McGuire's controller instead of the 057, but beautiful build, right? And he was helpful about this concept, right? He showed how he did his, and we basically replicated that design ourselves. And yeah, I mean that's the gist of the car. So very lightweight. I think it's 440 horsepower. So I have a draggy in here. I've never really tried to push it, but maybe today we could see what it'll do 0 to 60. I did just a brief one and just quarter throttle, 4.6 seconds. I mean the car, you'll see that it's in
a quarter throttle.
Yeah.
Wow.
Yeah, very fast. Right, faster than I'm used to. Right. So yeah. That's why we haven't driven it much. So I think the next thing we want to look at is maybe how to control the output, because you can. I could limit it to, let's say, 200 kilowatts or 150 kilowatts and just drive the car, get comfortable at different power levels and work up. Right now it's full on 350 kilowatt, so full power.
Wow.
Yeah.
You had mentioned earlier that you had students helping on this.
Right. So yeah, this was a senior design project. So the students did a lot of that research that we talked about, finding out how do you turn on the DC to DC, how do you integrate, how do we talk to the BMS, how do we take these codes and modify them appropriately. For example, we couldn't get the charger to turn on, so by researching the Arduino code, we said, okay, we'll set this flag to high. So they're very. We had 2 double E's. We had I think 3 mechanical engineers on the project. So we had a good team of students, and they worked on this. And really, I think they learned in parallel with the work. They learned a lot about batteries, a lot about EV conversion, a lot about hardware, how to network with people, how to reach out and talk to these people who have done it already. You know, and so that was very helpful. Yeah.
Yeah, you've done a lot of custom work here, so there's not very many people in this space that are doing all this integration and CAN bus hacking and all the rest of it. You'd also mentioned an Arduino in here. Is there one Arduino, or is there 2, or how many times you have to do that?
There's 2. There's 2. Essentially, in the charger, Damien's board is an Arduino. Okay. Okay, so that's the one. And then the second one is what's behind the dash, driving the dash, and that's from that EVTV company. Okay. And their Arduino is unique in the fact that I think it has the ability to talk to 2 or more CAN buses. It's got CAN bus 0, CAN bus 1. Okay. So we split it off where we're talking to, let's say, the motor controller on one and the battery on another, right? Okay. Or maybe the battery and this on one, and the motor controller on the other. We split it, but I don't remember now off the top of my head which is which. Yeah. But it's there. So our code is holistically talking to this and these on the battery in one shot. And then the Arduino there, we haven't integrated yet into the display. I'm not sure it really needs to be unless we wanted to. Right now, when we set a threshold like, hey, charge up to 390 volts, we do that through the laptop. Okay. But maybe you want to say, do it from the display. Then you would have to want that communication coming from the display back to the unit itself. The only control signals we're sending from the Arduino are, we're turning this on when the Arduino turns on, and we were engaging on the 057 traction control. We could turn traction control on or off.
Oh, you got traction control.
But it's a pseudo traction control. So for a light car, it's not really, it'll give false positives. So we turn that back off. Okay. But I mean, we were doing that type of control. The third thing I was mentioning to you, I'd like to do, limit the output of the motor. Yep. And you could do that. You could send that CAN code to do that, right?
Lots of opportunities in different directions here, isn't there?
Right.